I'm not really sure why. I'll be honest. That's what he did, and that's how he got the answer. But I just don't. Oh, no, wait. I think I remember now. Okay, so the answer that it gave him was the C-score, right? And then he plugged it in. He did the going backwards. You know how we had to solve for, was it X? Or yeah. So he solved for X once he had the Z-score. Does that make sense?
So the Z-score is 1?
No. So he put 0.40 in the area, in the normal probability outlet, and then it gave him negative 0.253. And then he plugged that in for Z, and he did the formula Z equals X minus mean over its standard deviation. I'm trying to find.
Excuse me.
Yeah, does that sound?
Where is the normal probability applet? Okay. Make that big again.
I thought I wrote down how he did it, but I guess I didn't. Oh no, I did. Yeah, because he did negative 0.253 equals X minus 10 over 5, and then solve for X.
Wait, say that again.
So it was negative 0.253 equals X minus 10 divided by 5.
And it wasn't like, oh, I guess we don't have a sample number. Never mind.
Yeah, so that was, yeah, so there was no sample number in that one. So it was just like kind of review for what we did last week, which I think is why it threw me off, because I'm like, yeah.
Okay. Well, cool. I will finish that up later then, because I think I understand the rest of it. That first one, I was like, I can't do the rest of this problem if I don't have the first thing.
Yeah.
Nope, that's not the quiz I want. That's not what I want either. That's not, nope. Okay. Let's see. So, and then question, is our exam is this next week?
Yeah. It is. Next week, and I think it's Monday through Wednesday that we can take it. Is that right?
Yes, Monday the 5th and ends February 7th, which I think is crazy. I'm like, Wednesday, really? I mean,
yeah.
I have classes on Wednesday, so it's not a huge deal, but like, really?
It's a random day. Yeah.
Okay. Group meeting quiz. Do you have any questions, or are you ready to take this?
I think we're good.
Okay. And for some reason, I cannot access my quizzes unless I go to this page, and I don't know. Okay, I'm going to make this big again and make this big. There we go. Okie dokie. I completed the individual preparation. Yes. Yes. Okay.
I'm a little nervous, not gonna lie.
Seriously. There was, okay, so I was doing the lesson Homework one? You've done that?
I haven't even done that.
So I just figured, like, I have a big physiology test that's on Saturday, and so I'm trying to get everything done so I can just spend the rest of today and tomorrow and Saturday studying for it.
Yeah.
And so I was working on this, and there was these 2 questions that I was like, I have no idea. Like, I don't understand this.
Yeah.
And then, like, I was talking to this guy that I hang out with. He's not even statistics or anything. He's just very intelligent. And I was like, just explain to me what this question is asking, because I don't like the words are not making sense. And then he explained it, and I was like, okay. And then it took me like 10 more minutes to figure out what the answer was.
Oh my gosh.
Like, I started this quiz last night and finished it at like 3 o'clock today because I just could not wrap my head around
what they were trying to say.
Yeah.
Wow. It's getting tougher.
It is. And they use the word mean like 5 times in one sentence or one question, and I'm like, okay, I don't understand.
Yeah.
Okay.
Oh my gosh.
Let's see. When calculating, do not round it to, okay. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z and to the left of z. Round your answer to 3 decimal places. So 1.358. Oh, am I sharing my screen with you?
No.
Well, let me do that. Okay, now can you see that?
Yes. Perfect.
Cool. Okay, what did I say? 1.358?
Yeah, 1.358.
1.358. Okay, and what did it say? Combined area that is to the right and to the left. So, oops. So it's just this area and this area, right?
Yeah.
So is that
Combined area under the standard.
So the view, this area up here gives us the view, right? Like if I unclick it. So it's 0.1745.
Yeah, 0.1745.
0.175.
Because we have to round up. 0.175. Oh my goodness.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? These questions, I really enjoy math, but when they throw word problems into math, I'm like, no.
Yeah.
Word problems aren't
randomly drawn from the population.
Okay. We'll have a smaller standard deviation.
So it leads me to believe the distribution of the sample means because they're all going to be around the same. I'm like, did I even do this? Did I even read about this?
I know, like it's just not sounding familiar.
Is it that central limit theorem rule? Oh.
Which of the following will have smaller standard deviation? Okay. Remind me again what standard deviation actually means. It's just
the difference
between the data numbers.
Yeah. Right. So like the farthest apart, I guess the numbers are.
Yeah, I would say it'd be the second one.
The second one?
Yeah. I don't think it would be the first one.
Distribution of the individual. Yeah, I don't think so. I mean, maybe it's the law of large numbers. Because I have here, like, if sample size is large, and then sample mean will typically be close to population mean because standard deviation gets smaller. But I think the second one.
Okay.
Because I'm like, I don't know.
I know, it gets to the point where you're like, I just don't know anymore.
Yeah.
Okay. Which of the following results implies that the spread in, so this is the mean, right?
Yes.
Mean decreases as the sample size increases. So it implies that the spread in the mean decreases.
That's the large.
A law of large numbers?
Yeah.
Okay.
Hopefully. Yeah. Sounds right.
Yeah, it does. Okay. Use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with mean of 150.8 and a standard deviation of 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score?
Okay. So we do.
So that's
the normal one, right?
So yeah, so you do 160. Ooh, 160 minus 150.8 divided by 8.8.
Yes.
So do we only do the one? The one that I get confused on is where it has the, say it would be like they took so many samples, and so it's 8.8 divided by the square root of the samples.
Oh yeah.
And
so that would only be when you have the sample then.
So, but that's still the z-score.
Okay. Yeah.
8 equals divided by 8.8 equals. Did you get 1.04554545?
Yes.
Okay.
So 1.045. Okay.
What is the probability that a randomly selected student will score above 160? So these are the questions that confuse me. Because it says we'll score above 160. So do we do?
So what you do is you plug in the z-score you just got into the normal probability applet.
Okay. But it's greater than 1. Oh, just kidding. These ones are greater than 1. Just kidding. 0.45. Okay.
And then you have to highlight greater than. So just to the right-hand side of the 1.045.
So just this?
Yeah.
And would it be 0.148? That's the answer? Okay. let me, so student. I never know when to use the probability applet.
I don't know. I mean, I'm still like trying to fully understand. But that's how I would have done this problem.
Well, I mean, their numbers.
Yeah.
Okay. A random sample of 5 was selected to take the generic. Your scores are 160, 175, 153, 149, and 153. What is the z-score corresponding to the sample mean of the student's scores? So we have to find the mean. So we add all those up divided by 5. Right?
Right. Well, I mean,
and then
see, now I'm confused. Oh, I mean, yeah. Right? And then we subtract the mean, and then we do over the standard deviation divided by the sample size?
Yes.
Okay.
I think. We'll see.
Yeah.
0. Oops. Plus 175 plus 163 plus 149 plus 153 equals divided by 5. So the mean is 160. Wait a second.
Mm-hmm. And then 160
minus 147 divided by 8.8 again. Is it the same answer?
divided by 8.8 over square root. Was it 5? Yeah.
Mm-hmm.
I got 2.337.
Okay, how did you get that?
I don't know. Okay.
Mm-hmm.
So we said it was 800 divided by 5.
Yes, which is 160.
160. And then we did 160
minus
150.8.
Yep. Divided by, right? Divided by
Divided by, and then the standard deviation was
8.8.
8.8 divided by square root 5.
Wait a second. Why?
Because there's 5 sample size. I mean, 5's the sample size, isn't it?
Yes.
See, this is when I get confused because I'm like, am I supposed to use the original one or the sample size one?
Okay, but no, I think you're right.
Yeah.
Yeah, with the square root of 5. So it's 8.8 divided by the square root of. Give me 1 second. $2.337?
Yeah.
Or 2.338, I guess.
2.338.
Okay. That does make sense. I do think that we're supposed to use that 5.
Yep. Okay.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Round your answer 4 decimals.
Oh, excuse me.
So what I would do is I would plug it into that applet again. The 2.338. And
Wait,
then
down here.
Down at the bottom.
2.338.
And then was it asking for greater?
Yeah. So the probability would be 0.0097.
Yeah.
Use the following information. Suppose the mean GPA of BYUI students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is skewed left, or left skewed. A random sample of 81 students will be drawn. What is the shape of the sampling? The random variable, it's left skewed. It told us that, right?
Represents the sample mean of 81 students, but since the sample mean's over 30, and isn't it normal?
But it says left skewed in the problem.
Yeah, but I think that's when the central limit theorem rule applies.
I do know exactly what you're talking about. I'm just not sure.
Because I think it's from the reading. I remember it saying something about for the sample to be normal, the parent population is normally distributed, and then the central limit theorem, sample size is large enough, so it has to be over 30.
Yeah, the central limit theorem guarantees the distribution of X is normal if the sample size is above 30.
Yeah.
Then why does it even tell us that it's left skewed?
Because it wants to confuse us. Because I think if it's below 30, then it would be left skewed. You know what I mean?
Yeah. Oh,
maybe that's the next question. No.
What is the mean of the distribution of sample means for all possible samples of size 81 drawn from the population? So,
what is the mean of the distribution?
3.5. Right?
I don't know.
I think it's 3.5.
Yeah?
Yeah.
I think that sounds right. 3.5?
Because I don't.
That's the sample mean.
The other means.
Because how else would there wouldn't be another way for us to find it out. I don't think.
No, I think it's 3.5.
Okay.
What is the standard deviation of the distribution of sample means for all possible? So the standard deviation was just 0.7.
Yeah.
It says round your answer to 3 decimal points. Put 0.700.
Now that's making me doubt.
I know. Because this one was like round it's a 1 place. That's
a 1, so
not too iffy. Okay, what's the question again? What is the standard deviation of would that be 3.5 divided by 0.7 divided by 381?
But we're missing a value.
Mm-mm.
Because it has to be value minus mean. What's the value?
I don't think we have to have another value.
No.
No. No, it's just, wait a second. Maybe I'm wrong. Hang on.
Let's see.
Yeah, I don't know. I think I'm wrong. But the standard deviation of the distribution of sample means. Oh, the standard deviation. Would it just be 0.7 divided by the square root of 81?
I think maybe.
Square root of 81 is 9. What was it? 0.7? 0.7 divided by 9 equals 0.0777. So round to 3, 0.078.
Wait, did you get 0.0778? Or what?
I got 0.07777.
Oh, okay, yeah, so 0.078 then.
Yeah.
Okay.
I'm pretty sure. I'm like maybe 75% sure.
That sounds right.
Okay. What is the probability that the mean GPA for the 81 randomly selected BYUI students will be less than 3.3? Okay, so then this one would be 3.3 minus 3.5 divided by 0.7 divided by 81.
Yes. Okay. Yes.
So 3.3 minus 3.5 divided by 0.078.
Mm-hmm.
3.3 minus 3.5 equals divided by 0.07 equals negative 2.56. 4?
Negative 2.5714. So
Did I push a wrong number? 3.3 minus 3.5 equals divided by 0.078 equals. I still got negative 2.564.
negative 3.
Negative 2.
Yeah.
Point
Okay, so 3.3 minus 3.5
divided by 0.078.
Yeah, and I still get negative 2 point, but I think because I'm doing it like 0.7 divided by square root 81.
Oh. Oh, I just used the one that we did
Yeah.
from our last answer or question. Whew, it's chilly in here. I don't know which one.
No, I still get negative 2 something.
Yeah, negative 2 what though?
Negative 2. Wait. Oh, snap. Hold on. Negative 2.571.
571.
Yeah.
Okay. Let me go get my other calculator really quick.
Okay.
Okay. Let's go. Jeez Louise, excuse me. Okay. So should I put it in the calculator not using the 0.078? Should I do the square root?
Yeah, I think it slightly changes it.
So 3.3 minus 3.5 divided by what is it? 0.7
7. Mm-hmm.
divided by
Square root 81.
square root of 81. Oopsies. Dang it, I messed it up. Hang on. 3.3 minus 3.5 divided by 0.7 divided by the square root of 81. Okay, that's not right. I got 0.00864. Oh my goodness. Okay. What if I do 0.7 divided by Okay. I think I know why it's giving a different number. Give me 1 second.
Okay.
So 3.3 minus 3.5. Okay, divided by 0.0. Yes, negative 2.571.
Okay.
And I know why. It's because I did not keep the full number. I rounded and I used the rounded number to do the
Oh.
So glad we figured that out.
Yeah. So then that number,
We put it into the normal probability.
in that probability output.
So we put it negative 2.5, nope, 571. Nope, it's fine. Yeah. So, oh my gosh. Okay. What's the question again? We spent so long. Okay. What is the probability that the mean GPA for 81 will be less than 3.3?
So to the left-hand side.
So we unclick that and click this.
And you unclick the middle.
Unclick the middle?
Mm-hmm.
Wait, why?
Because it's just less than 3.3, and the number we got, the z-score, it was negative 2.571.
Oh, so it's just this part.
Mm-hmm. And it makes sense because it said it was left skewed, and the mean's 3.5.
So 0.0051.
Yeah. 0.005.
0. What is the probability that the mean GPA will be greater than 3.3? So now, is it this? All of
Yeah.
that to 0.9949?
So 0.995?
Yeah. Hopefully.
Hopefully. Oh my gosh. Oh, that's funny.
Oh my goodness. I dropped mac and cheese on my pants earlier and they're like all stiff and gross. I pulled it out of the microwave because I was warming up leftovers and I just biffed it, like dropped the bowl. It was great.
Oh my goodness.
Okay. The United States Coast Guard assumes the mean weight of the passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7. The weights of random sample of 48 commercial boat passengers were recorded. So the standard deviation, which is mu is the mean, right?
Yeah. It's that sigma or whatever they call it.
Yeah. Okay, so N equals 48, right?
The weight of a random sample, 48. Mm-hmm. The sample mean was determined to be 177.6.
Okay, so 177.6. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed in this sample.
Okay. So 177.6 minus 185, right?
Wait. Is it the mean that goes first?
It's the value. I think that's the value. That 177.6, because the mean weight
is 185.
Yeah. Right?
Yes. Sure.
We'll do it backwards if it's wrong.
Yeah.
Okay.
Okay. So then it's 26.7 divided by the square root of 48?
Yes.
Okay. So 26.7 divided by do you get just for the 26.7 divided by the square root of 48, did you get 3.853? 8?
Let me.
I don't remember exactly how to use this calculator.
26.7 divided by, it was 48, right?
Yeah.
3.853813047. Is that what you got?
Yes.
Oh, okay. Yeah.
3.853813047. Okay, and then we do 177.6 minus 185 equals -7.4.
Mm-hmm.
And then we divide that. Divided by -1.920?
Yes.
Okay, well, is that our answer?
No. It says, oh my gosh, I can't find it. And then it says,
find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed in this sample. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones observed, but also ones that are as far away from them.
Okay. So we go to the probability applet.
Okay.
And we put the 1.920
as a z-score.
Mm-hmm.
Negative 1.920.
Mm-hmm. And then since it's asking above, so I think it wants us to do the little tails.
Oh, just the little tails?
Mm-hmm. Right? Because it says
find the probability that a random sample of passengers will have a weight that is as extreme or more extreme. So as extreme and more extreme, or more extreme, wouldn't that be the middle and the right-hand side?
Because then in the note that it says, so we're interested in values that are lower. So it's for sure the left-hand side, right? Than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
So not the middle, just the ends.
I think it's just the ends.
So would it be this?
Yeah, 0.055?
Yeah, 0.055. Hopefully. Oh my goodness.
Yeah.
All right. We got this. I'm so nervous right now.
My hands are like, my palms are sweaty.
I don't even want to look at it.
I know.
Okay.
Oh my God.
We're good so far. Question 5, 6, 7, 8, 9. Ooh.
Yay!
We're good. Oh, dude! We got 100.
Oh my gosh.
That was so stressful.
I know.
Oh my God. Well, awesome. Okay, well now I have a better understanding of when to use the probability applet.
Yeah, I think it makes more sense to me now too.
Because I had no idea when to use. I was like, why do I even need to use this?
Yeah.
Well, anyways.
Okay. Well, that one was a long one.
That was a long one. Oh my goodness. All right, well,
do it once.
if I have any questions, or if you have any questions about the homework, feel free to text me. And if we need to get on and not broadcast, we can just talk about it.
Yeah.
So,
okay.
Yeah.
That's good. All right. See you Monday then.
Yes, Monday at 6 p.m.
Yes.
Okay. Perfect.
Okay, I'll send you the link. And then should we email our teacher? Sister, teacher.
Yeah, we can. We can do a little group email?
Okay.
With all 3 of us in it. And maybe even Robert? I don't know.
Yeah.
We'll figure it out.
All right.
All right. We'll see you on Monday.
Okay, see ya. Bye.
Bye.